Philadelphia, and I curate the Mobile Mondays here in Silicon Valley, New York City, and also Silicon Beach, which is in Los Angeles, and also helping out Chicago. So it's going to be a busy year. We did, I think, over 50 events between the different cities last year. So the agenda for tonight, I'll go over a quick welcome. I think we are attempting to live stream 360 this time to folks out in New York and also Los Angeles. And then after the overview, MobileMonday overview, we'll go into our panel discussion and then wrap up tonight with some more networking. Mobile Monday, we're in a network in about 140 different cities around the world. Folks in the audience, based upon how you responded to the Eventbrite registration, how many people here write code, developers? Wow. How many people here are startup founders? Wow. How many people do product marketing or product and marketing? Business development, sales? UI, UX, designers, bloggers, media, and VCs. Are there any VCs in the house? Yeah. All right. So cool. So you are at our monthly topic, which is more of a panel discussion. We also do developer labs, and we have a couple of those coming up, and then we also do roundtable dinners. If you guys are interested in knowing more about those, you guys can hit me up after the meeting. We're corporate sponsored. That's how we allow you guys for food and also free attendance. Where to find us is Mobile Monday US. How many people find us on Meetup? Registered Meetup? Cool. And we're also recording these, so these are all up on YouTube. We got about 5 or 6 years worth of events on YouTube. Follow us on Facebook. We always have nice discounts. We also have conference free tickets and lots of other things. And then every time we have a video ready to send out, we send those over to you. People that tweet at MomoSB is our alias, and hashtag Mobile Monday. If you guys want to do that, they'll get picked up globally. Upcoming events, you can still find us at mobilemonday.us. You'll find a link to all our events. So next week, May 18th, as Packet Zoom, as part of Google I/O Extended, if folks aren't attending Google I/O, there will be a bunch of events here next week. We're live streaming, or also we're picking up on doing some on-demand on some of the key stuff. So next Thursday night, we'll be back here with an amazing presentation from Packet Zoom. And if you're curious about Packet Zoom, come by next Thursday to hear more. But basically, if speed and user experience are important to you from the app ecosystem perspective, then Packet Zoom will definitely be of interest to you. June 2nd through the 4th, we'll be in New York at a hackathon, 10,000 in cash prizes. That same hackathon will be coming back here in September. So September 8th, 9th, and 10th, so we'll have more information about that. So basically, IBM Watson, IBM Strongloop, and Bluemix, basically the whole suite of IBM products will be part of the hackathon. June 26th, we'll be in LA, Silicon Beach, for another dev lab with Amazon Web Services. So AWS has some awesome mobile services that many of us probably don't know or use, and we're putting some effort behind it for community awareness. And the same thing will be back in July with Chicago, and mid-July we'll have another event with Here Maps discussing mobile advertising and location. Event supporters for tonight are Chetan Sharma Consulting. We'll give a round of applause for Chetan and his team. And also Space. So that's all, everybody. Important news, restrooms are at that pillar down the hall. So the middle black pillar, just go down the hall, and the restrooms will be on your right. If you want to have a conversation, there's monitors back there, right? You guys in the very back can see. So if you guys want to take it down to the commissary, I think there's more beer and drinks as well if you guys want to have a quick chat. But let the folks over here enjoy the rest of the concert for the evening. So without any further ado, I'd like to introduce Chetan Sharma, who's coming up, and give him a round of applause. Thank you.
So thanks a lot, Mario, and thanks a lot, Google Launchpad for supporting the event. I think Mario does an amazing job in the community, to not only in the Bay Area, but I think nationwide. It's a bigger round of applause for Mario.
Oh, thank you.
The hashtag is MobileMonday, as well as you can hashtag Mobile Series, and we'll try to pick up questions or comments from there. Just a quick note on upcoming events that we are also hosting. Mobile Future Forward, which is our annual event to talk about the next 5-10 years in the mobile space, but also a lot of adjacent spaces like AI and blockchain and cybersecurity and whatnot. So there's some flyers over there if you're interested, or you can go to mobilefutureforward.com. We'll also give away a couple of books at the end if you answer the questions and if you've been paying attention to the panels. Before I start, I just wanted to give a brief background on AI from my vantage point. AI as a concept has been around for a long time, as many of you know. In earnest, it started in 1956, a summer project in Dartmouth that McCarthy led with a number of other prominent scientists. Before that, Shockley wrote a memo to his boss at Bell Labs about automatic trainable robot, in the famous memo. And before that, Turing had actually talked about machines that can simulate human mind and behavior. Prior to that, his thinking was influenced by Vannevar Bush in the article Electronic Monthly, which was again thinking about some of these concepts about mimicking the brain and human intelligence. Prior to that, probably the godfather of the industry, Tesla, who had 100 years ago pretty much on his own conceptualized the entire wireless industry. And some of these concepts are starting to come true when sensors and algorithms come together to form the global brain. But even prior to that, in 1872, Samuel Butler wrote about some of these concepts about the brain, as well as some of the things that are becoming prominent today around jobs and automation. He actually was thinking about that long time back. And he expanded on that from his previous article, which was in 1863, Darwin Amongst Machines. So AI, as you've seen, I mean, if you can go further back to Aristotle, you will see some of the notion. Humans have been fascinated with the concept of automating the brain for a long time. And so philosophy of one century becomes common sense of the next. And so I think we are in that phase. The concepts have been around, we're trying to execute on them at a level that makes sense in products and services. But I think fast forward to 2016, even though the current White House doesn't believe in AI, I think two prominent studies came out last year, Life in 2030, as well as the last report from Obama's White House around automation and economy. And some of these questions that are being raised around technology, about ethics, policy, regulations, are indeed of great importance to humanity. So if you're new to the notion or the world of AI, I think these are two good papers to study and read. So why is this happening? I think the one fundamental reason is that the amount of digital information over time has been exponentially rising. And every year, kind of doubling or 10xing the information that we produce. And as such, on a per gig basis, per day basis, or per human basis, we are constantly producing and consuming a tremendous amount of data. And this data is yielding new insights about behavior, as well as the computing is enabling some of the problems that were not solvable before to be in the realm of solving them. And so we've written about it quite a bit. I've written 3 books, a couple of papers on connected intelligence, which is a broader concept around how the next 30, 40 years in the tech industry are likely to evolve. And so broadly thinking, I kind of think about the ecosystem into blocks. So you have the objects or the sensor layer at the bottom, you have the connectivity layer on top, and then you have the data which yields intelligence, you have trust and security, and then a bunch of other industries on top. And that's fundamentally the architecture of the tech world. And each of these industries or each of these blocks is $1 trillion+ industry. So today we are going to focus primarily on how intelligence figures into the space, which is an underlying layer across pretty much every industry and soon to be all sorts of products and services. Uber is obviously talking about flying cars, but even before that, I think you could see the noise has been rising over time, and we are at 4x decibel level. What AI means in product, services, discussion in the tech space, but also policy and regulation space, and we'll get to that with the panel in a minute. But what's more interesting is the number of mentions of AI in company earnings has gone 35x. And so everybody with 2 lines of data and a spreadsheet claims to be doing AI. And that means that we have to separate kind of hype from what's real and what's not. Because obviously, AI cannot be applied to every single problem that we have. And so we'll try to kind of distill through some of that hype and the reality curve on the panel as well. A number of AI startups getting funded, close to 2,000 startups, 15 billion plus. And I think a lot of the stuff is obviously happening in the consumer space, but in the enterprise AI space, some fascinating data sets are available in health, retail, transportation, and so we're seeing a lot of activity in those spaces as well. We'll touch a bit on automation and impact on society, though we cannot delve too much into it. We could talk for the rest of the evening what that means. But you can see this is a graph of the impact of automation on various industries and by correlation to certain geographies or districts. And you can see that areas where there was a lot of manufacturing, a lot of automobiles, manufacturing taking place, or things in pharma, plastics, and chemicals have been the first industries that have been impacted. And you can see in some of the detailed graphs that there's a tight correlation in the exposure of robots in certain industries or geographies to the job losses, especially when the productivity is not rising. And so certain industries are more susceptible to change in the short term. Longer term, when the automation costs cut across the labor costs, typically that's a tipping point for that industry. So to figure all this out, I mean, there's a lot to cover, but we'll try to get to as many questions as possible. We have a fantastic panel to talk through this. Panelists, please join in. Just grab a seat. So I'll just do a quick intro. We have Tsvi Achler, who is a neuroscientist and doing some amazing work in figuring out the black box of AI. Like how do you explain AI decisions, and what does that mean to the decision process? And so we'll dive a bit into that. Then David Gerster from BigML, he has built and led a lot of data science teams at Groupon, Yahoo, and now doing fantastic work at BigML. We have Barak from Google, has been doing some amazing work, probably one of the largest AI projects, Google Translate, and have years of experience both at Google and previously with Microsoft. And Dio from Ericsson has been doing fantastic work around obviously innovation, but how it relates to the telco world. Operators, as you know, have tremendous amount of data. The networks that can be applied both to the network side as well as consumer behavior side. And so how do you mine that data and understand that data in a way that can be applied to the networks as well as the consumers and can be opened up to the rest of the ecosystem. So we'll dive in all of these areas in a little bit. So maybe, I think you're short of the mic. Maybe you guys can share. So Barak, let me start with you. Since you had experience to lead Google Translate, if you can just distill down into some of the basic definition aspect of AI, in terms of AI or general AI, deep learning, big data. From your vantage point, how do you see these different terms applied to data? And then maybe explore a little bit about Google Translate and how that has taught you and Google and rest of the ecosystem about how AI can be applied to big problems?
Yeah, I think your graph was very revealing. I saw it before about number of mentions of AI in earnings calls. There's a ton of hype. In many cases, people claim that they use AI or try to use AI for problems that it might be too early to use AI, or it's not necessarily useful to use AI. In Google Translate, we're fortunate enough to use AI for two big areas that I think require AI. The first area is unstructured data. For example, in Translate, we use speech and we use visual translation. Both of those areas, the data is unstructured. There is no really good way to use, to understand speech or understand images or text on a picture without AI. And the second area is an area of, it's actually kind of evolution. So Google Translate started with statistical machine learning, like what we now call older version of machine learning, 10 years ago, when we crawled the web and found data that was already translated by humans at huge scale, billions of translations, for example, United Nations documents or news sites documents, and we applied statistical patterns to basically learn the language. So in that case, that's another classical implementation of AI, where you have, let's say, older statistical methods that worked really well and allows you to scale, but at some point they plateau. You cannot improve them any further, and that's what Google Translate experienced, I would say, 5 years ago. And then AI, deep networks and deep learning allowed us to leapfrog to the next level of quality, gave us significant jump in quality. That was basically when we launched neural network-based translation, it gave us more quality improvements in a single leap than in the last 10 years combined. So those two big applications of AI, I think, is kind of classical. There's probably more. One is unstructured data, and the second one is an area where you could use older approaches, maybe older machine learning approaches like statistical approach, but then you plateau and you can get a next level of jump in quality, which is disruptive jump in quality by applying advanced AI.
So beyond what you just described, what are the other areas that are on the horizon? People have talked about computer vision, they have talked about language. What are other areas on the horizon that AI can be applied to solve problems that were not solvable 10 years ago?
Yeah, I would say I still think those two general areas apply. One is unstructured data. Mm-hmm. There's basically areas probably where currently we are not able to fulfill our potential in using the data because it's unstructured, and you cannot really structure it in a way that you can use, let's say, statistical approach. And the second area is that areas where you actually achieved some either scale or some gains, but now you plateaued and you're basically looking for next jump. And it could be, I mean, the areas varies. It could be improvement in search, it could be improvement in personalization, it could be improvement in spam. There are multiple areas that are either unstructured data, so the solution is not quite there, or the area where there was already improvements or already good progress, but AI gives you a not incremental but disruptive jump to the next level.
David, fast forward 10 years and talk about some of the consumer engagement or consumer interaction with AI on the other side, without humans on the other side, not knowing who they're interacting with. What would that experience look like in 10 years?
Yeah, okay, let's get a little bit futuristic, right? That's the fun part of all this. So, I think it's really interesting to think about the humble customer support call, right? And how that's going to change once there is an AI on the other end of the line that can speak, perfect English, for example. And who knows if that'll be in 10 years, right? But, imagine that happens. And so, the first thing I think that's going to happen is that people are going to figure out that when the customer service rep who answers your phone call speaks perfect English and is like totally cheerful all the time, that they're probably a bot, right? And so this game of cat and mouse starts to evolve, right? And countermeasures must be taken because you don't want people going to a live human, right? It's just really, really expensive. And it defeats the whole purpose of having this technology, right?
So would AI adapt to humans adapting to AI?
I think so. Well, so it is this game of cat and mouse, right? So you can imagine a lot of countermeasures, right? For example, you could have the AI clear its throat or pretend to lose its train of thought, right? You could have a realistic background noise, right? With other voices in the background and typing and all this kind of stuff. You could even have, you could even give the AI an accent, right? You could have it speak in accented English, so it's a more realistic scenario where you believe you're calling someone in India or the Philippines or Ireland, right? And at some point, after all these countermeasures have been deployed, the bots have won, right? You'll know the bots have won because the rate of false detection, the rate of true detection is actually exceeded by the rate of false detection. You'll actually have scenarios, I think, where live humans are being told, can I please speak to a human operator, right? And so it's coming, right? But here's the thing, I don't think that's where it ends. I think the end game is actually the pendulum swings back to people actually preferring the more unnatural and synthetic sounding bot, because they have learned over time that you get better customer service from the bot, right? It's faster, it doesn't make as many mistakes, and people just kind of have to get used to this fact. And so you end up with kind of the opposite of the uncanny valley. If anyone remembers the uncanny valley from like Polar Express, you know, this idea that if a cartoon character is not perfectly natural, if it's like almost natural, it just looks creepy, right? But you end up with kind of the uncanny mountain for customer service because people actually learn to prefer the more unnatural experience. And so that's kind of way out there, but...
Yeah, I think it has been shown that patients are more truthful to bots than they are to their doctors.
Yeah, so it's funny that I think there is this game of cat and mouse that gets unleashed by that kind of technology, and I see the bots winning that game, and then I see that game becoming irrelevant as people get more and more used to the idea that the bots are actually giving them a better experience.
Dio, one of the areas which has a lot of data and is constantly in need to fine-tune is the telco world, an area that you live and breathe. So talk to us about how AI is being thought about being applied in the telco domain or the service provider domain, and what does it do to the performance of the network layer, as well as how consumers interact with the network, the devices, the applications and services.
Yeah, so from an Ericsson perspective, we see the network evolution in 4 distinct stages. First one is what we have been experiencing so far. We call it sort of descriptive. It's all about what happened in the past. I understand, there was a performance issue, an operational issue, an alarm, and I'm trying to gather all this historical statistical information to understand what's going on in the network. The evolution of this, which we are primarily now and in the next stage, is about predictive networks. So we try to understand, what has happened in the past and what will happen in the near future, without necessarily taking an active step of how to remedy. The third thing is prescriptive. Prescriptive networks are the networks who understand what happened in the past, they pretty much know what it will happen, they predict what it will happen with a certain confidence level in the future, and they recommend a way to overcome that prediction. And the fourth stage, and this is where primarily is the telco space today. So we understand a bit about the past, we can predict quite accurately what it will happen in the future, and we'll find means to evolve and remedy the issues. And the fourth element is just do it networks, right? Networks which understand what is happening in the past, they understand what will happen in the future, they have multiple ways of understanding also how a human brain would react in that certain circumstances, whether it's performance or operational. They have a thought process that is going through certain dependencies, graph dependencies and all those kind of stuff. And they actually taking over in order for them to make sure that the prediction that they have will not actually have a negative impact on the network and the performance people expect. So that is from an operational and performance perspective. And of course, as network tries to evolve, I saw that image, right, that says connectivity, objects, connectivity, and intelligence. We try as an industry blend the intelligence and the networking together, because we believe having smarter networks, especially as we advocating for the network society, we believe will benefit the things that they are connected to. So if we make networks more predictable, if we make networks more resilient, and if we make them more self-learning, we believe the overall network effect of that society will become better.
So what are the specific areas in network optimization or the network evolution where this technique is being applied to? And secondly, is it being applied today, or are we waiting for the next generation of technology like 5G to come?
So, to answer your question, I mean, there are certain techniques that they are applied right now, even in LTE advanced networks that we have around the world. As I said, there are two main categories: performance and operations. When it comes to performance, anything that goes from connectivity, really the lower layers of OSI, to transport protocols, like how we can predict a better congestion window for TCP or UDP and all those kind of stuff. We are actually doing a lot of work there to understand session control, to understand how historically a session is being utilized, and of course also setting our nodes and our infrastructure what we call parameter free, right? In a way that the machine can take over and understand the semantics of the network, the context of the network, and the traffic and the application, and try to adjust dynamically to the network conditions, which is one of the most challenging problems, because our friends from Google creating new applications, and they creating a network effective applications. Networks need to react either to bursty moves or to more lengthy moves. Translate means low latency. How can we gear a network to have lower latency when we have, in fact, designed it for high bandwidth, for example? How we can do this transformation? So it's a very challenging problem for us. And of course, we're working today, and of course, we'll intensify our work in the future for 5G and beyond.
Tsvi, a few days back, or a few weeks back, there was an article that AI has a PR problem. And the gist of the article was that AI is not able to explain why it decided what it decided, right? It's the decision process. And you have been concentrated on that specific problem. So maybe you can help educate us on why it's so difficult to explain the black box of AI, and what you or the industry is doing to open that up so that people can understand at the consumer level how the decisions are getting made.
Thank you. I think the difficulty to explain the AI comes from the structure, from the basis when you go down to it, where it's taking inputs, multiplying it through weights, coming up with outputs. And there's a whole optimization process to get to those weights. Now, once it's optimized, the whole system is optimized to make a decision in one step. And that makes it difficult if you want to go back and understand what went into building that, what went into the decision. It's hard to go back and understand that whole training process. And that's why it's difficult to understand what the AI is doing.
And so, in some of this is being talked about at the regulatory levels as well, especially in EU, where they have much stricter data laws. And so one of the commissioner had opined that AI will have to explain its decision process to the consumer, why it decided the way it decided. And so how do we get to that point? I mean, AI is a complex art and science, and how do we get to a point where consumers can say, hey, your application got rejected or approved because of X, Y, and Z, versus kind of making a guess at it?
Right. There's two problems. The more that you want AI to apply to scenarios where a mistake by the AI is going to affect people greatly, so like in medicine, self-driving cars, or banking, the more you're going to have to be very careful about it. Make sure it's not making decisions based on things you don't expect. And that's where it's going to be important to have that explainability. So that's the first part of your question. The second part was, how do we address that?
Yeah, do you think regulation will drive the industry to that state where you can explain the algorithms and the black box? Or do you think there's a consensus amongst the practitioners of the trade that this is something a must-have before the regulators can act? Like, how do we get to that state? Industry driving or the regulations driving?
Yeah, I think it's going to be a combination. I think, so there's risk of error and how much that error is going to cost the company and who's going to be responsible. That's going to drive the industry itself. But there's also going to be the government who's also going to see the same sort of issues and come up with ways to regulate the AI. You don't want the AI to be driving and then cause an accident and then make a mistake and nobody really understood what it was doing, and then who's to blame? And how do you remedy this?
Yeah, I wanted to add that even though it's true that in many cases a lot of AI engines today are kind of black box, but some of this is related to the fact that it's a very new technology.
Mm-hmm.
And I think the technology will evolve and it will provide better explainability, people tools to address some of those explainability questions. When I was like a young system administrator 20 years ago, the first thing I would do if a server would not work as expected, I would just reboot it. And to some extent today, when something in the neural model doesn't work, you just retrain. But over time, as with Google Translate 10 years ago, we built tools to deal with funky things like, for example, how do you deal with conversions of units or currencies. And over time, I think even for ML models, for AI models, we will build tools that will help with addressing some of the common mistakes and also to better explain some of the decisions.
So I think that in certain applications, for example, Siri, it's a great application because if it makes an error, nobody gets hurt. And so you can reboot it. You can just say, okay, oh well, it makes a mistake or translates or so on. But there's the range. So right now, AI is mostly adopted in fields, in applications, where the mistakes aren't that critical. Okay, Siri made a mistake. Well, no, we change it and keep on going. The key here, all the regulations and the difficulties will become with in part because of the success of the AI, because it's doing so wonderfully well. I don't mean to discount that. But when people's well-being and lives are going to be at stake, there's going to be more of the regulations.
Yeah, I just wanted to add that one thing that I haven't seen get a lot of attention, with this issue of black boxes and how do you explain the workings of these black boxes. One thing I haven't seen get much attention is what was the cost function you were using, right? So in the case of classification, what is the relative cost of a false positive versus a false negative? And intuitively, you can see that that's going to be a very different set of assumptions for, say, medical diagnosis versus, I was advising this company that's trying to improve corn through genome-wide association studies. And in that case, they don't want false negatives. They don't want to accidentally not plant a promising plant, right? And so it completely depends on the domain what cost function you're going to use.
Sure.
And this is something that a lot of practitioners don't even get right, I think. And so how do you actually take that and explain it to the general public, I think, is sort of the looming problem. But yeah, something like that is so fundamental to how is the model trained, how is it evaluated, how do you actually come up with this particular set of predictions.
And one more thing to add, I agree with all the guys, right, about AI. AI, I see it in 3 dimensions. One is autonomy, one is learning, one is reasoning. Most of the work we're doing right now is between somewhere, apart from some advanced models, right, more about learning and autonomy. Reasoning start to becoming more obvious, in the way we calculate models, we estimate models, and we reason models. And I think the more obvious that reasoning function becomes, the more credibility we give to the confidence levels that we produce out of the two, right? And reasoning is something that recently has started becoming really a trend. It would be interesting to see also in the AI deep dive if it is actually becoming because this really gives the thought process of the logical steps that somebody followed in order to come to the conclusion.
So that brings a question around the ecosystem and where the competitive value will lie. Like who will be, each cycle brings in winners and losers. So far in AI, some of the big players are the incumbents, the Googles, Facebooks, Microsoft, Amazons of the world. And so going forward, obviously it's very dependent on the data set people have. Startups typically have this lack of data becoming available, and so they typically try to go after the enterprise vertical space to get the data set. What does panel think about the competitive landscape? There are a lot of startup founders here. How should startups think about entering the space? Where does the value lie? Is it in the developing the algorithms? Is it trying to procure and secure and do data brokering deals so that you can train your algorithms? If you were starting a new trying to address a specific domain, a specific problem, where is the value going to get built?
Yeah, my answer is probably a bit biased because Google always thinks and operates at large scale. So just to give you a sense, we translate 140 billion words every single day. Scale is huge. And when you operate in a large scale, actually the biggest problem is actually computing power. Mm-hmm. It's not the data set that I actually believe to some extent might become even open source in many areas. I don't think it's also the models, because a lot of the models are kind of even public domain. Yeah. I think that if you want to operate at big scale, the computing power is a big issue. But obviously, I think the cost of computing power is going down, mm-hmm. and in that regard, probably all big players, cloud players, will make computing power cheaper and cheaper and more accessible. But again, it's either focusing for startups, it's either focusing on a specific domain where there is a high value even at a limited scale, or just understand there are costs associated with computing power. Even if it's very cheap per unit, you need a lot of it if you want to operate at scale.
Any other thoughts?
Yeah, I would say for us also looking a complex environment like network operations and network LT architecture, domain is one of the main things. I mean, Google does a great job creating models like TensorFlow, frameworks like TensorFlow, etc. We don't necessarily need to create that, right, as a company. We need to take advantage of that and understand which model fits our data model. So domain knowledge is very, very important to be able to simulate, understand, and model in an ontology what you have in an architecture today. So that's one, and definitely I agree with you. I mean, scale, cost of scale and computational, I think is definitely
So when people are starting on some massive, or starting to think about solving a problem in a domain, they maybe have access to data. What are some of the common mistakes they make that they didn't realize? I think somebody mentioned cost structure to figure out data labeling and whatnot. What are some of the common mistakes that people make in addressing a domain with AI?
Well, I think one very common mistake is to just throw the algorithm at the problem, and you kind of take this top-heavy approach. It starts with the nitty-gritty of just getting your data set together, doing some basic feature engineering, making sure that when you finally do point the algorithm at that data set, you're going to get a meaningful answer. Again, I brought up the issue of, how do you assess the cost of a false positive or a false negative? That's also a big part of the setup. There's this temptation, I think everyone is kind of like this, right? You just want to oh, okay, I got TensorFlow up and running, let's just see what happens. And, that's going to make your life very difficult.
I would also say one of the fundamental mistakes that I see is that people don't spend time to define the problem, what they're actually trying to achieve in their goals. And that's basically create biases and what training data they use, what testing data, what evaluation sets they use. So I think that's the basic thing, is that you need to define what experience or what kind of outcome you're trying to achieve. That's the first thing. That will drive a lot of your decisions. And then there's a lot of small tactical decisions. How do you have the right data set? how do you have the right evaluation and test set? Because it's effectively the same garbage in, garbage out, but with a black box approach. So you're like, okay, I put garbage, there's some black box. I got garbage out, and you cannot even, to some extent, debug it. So I would say that's probably the two main things. One is define the problem really well, and to be very careful what you choose for training, evaluation, and testing sets.
Another problem I think that a lot of developers may not realize is that in order to get the algorithms to work on certain sets of data, there's a lot of data cleaning and engineering, it was referred to. But you need to balance the data, for example. If you're going to recognize a bunch of things, well, you're going to have about equal examples for all those things. And so there's a lot of work that requires to procure that data, even if you do have a data set. And all of these are important in order to get the algorithms working with the type of algorithms that are used today for the AI. The brain has figured out ways around that, but these are the current issues that are with the AI as we have it today.
So, we have been trying to mimic human brain for centuries. Brain has this capacity to make up for the missing data. Like a child might not learn how to go up the hill, but after falling the first time, there's a feedback loop, they figure out how to really climb. And a lot of developers run into this problem of incomplete data or the bias in the data collection or bias in the programmer's mind itself. So how does one think about removing the biases or dealing with the biases as well as dealing with the incomplete data set?
Right, so this is pretty complicated with the way things are. Explainability would help with some of the biases, for example. If you're able to understand why it's making the decision, you can see what part of the inputs it is using. And just to give examples, so a group in Google, for example, trained an AI to recognize images. And when, it does great with the recognition, but if you modify the image 4%, very, very tiny, a human won't see the difference. You take a picture of a bus, let's say, you modify it just a little bit, and then you give it to the AI and the human will say, oh, this is a bus, it still looks like a bus, I don't see any difference. But the AI now says, oh, I'm almost 100% sure this is now an ostrich. And that goes towards the biases. What's inside that's making those explanations? Why is it doing that?
Dio, a lot of the networks are somewhat similar, but there are differences in how operators deploy the network. And so can you apply what you learned from, say, an AT&T to a Deutsche Telekom network? Or how do you go about training the data set or acquiring the data set that can be applied in a different environment, different setup, different country?
Yeah, so the good thing about a company like Ericsson is that it sees multiple deployments, very heterogeneous environments, very different traffic patterns, right? What we're trying to do is we're trying to understand how different geographies, different traffic patterns and different installations, right, are mapped into an ontology to try to understand which one fits what. It's not easy to just say, something happens in Singapore and something happens in China and that probably this thing will happen in the US, right? And it requires a very complex, property definition and all those kind of stuff in order for you to be able to create models that by scale, they can lead to better decisions. Because sometimes you get the opposite effect. So we do a lot of work on actually doing this because as we see different heterogeneous environments, we try to see, what is the learnings we get from here that we can apply from here? And it's very, very complex. We have this example where you have same issue, like a VoLTE, voice over LTE establishment call failure. And then we have different characteristics of exactly the same problem, but two different installations, which are similar installations, but different traffic patterns. So it ends to be that although it's the same problem, the root cause analysis is completely different for the two installations. Although they have similar architecture, similar mapping, similar problem, same problem, but different traffic patterns. So it's a very complicated problem we try to address. It's a very good question, actually.
So from an applications point of view, did you want to add something?
Oh, I was just going to add, one way to get around problems with your data set is to do things involving unsupervised or semi-supervised learning. I'm thinking specifically of AlphaGo, which use reinforcement learning combined with deep learning to create, obviously, the world-class Go champion. And so it's really interesting to think about that solution versus how many labeled training examples would you need to actually achieve the same result, right? And so that's one of the things I'm really enthusiastic about is clever use of unsupervised learning to get around some of these problems with curating massive data sets. Yeah.
I would just add that we at Google are very optimistic about the power of transfer learning, meaning you apply one training model and combine it with other training models that doesn't have either enough data or doesn't have no data. So generally speaking, and you kind of touched on it, is that human brain is great on big picture but sucks in details, and the neural network is the other way around. And when I look at, it's a huge opportunity that I have two sons, one is 5-year-old and the other is 3-year-old, and they speak Russian and in English. And generally speaking, our system is probably at the level of my 5-year-old right now, in terms of like how they do it, how they freely speak two languages. And to me, it's a huge opportunity that we basically in such a beginning in terms of like where neural networks or AI is. I would also say that at least for languages, we discovered that when you train models on multiple languages, you get a lot of things that can make up for not enough data. There's a lot of languages like Hindi or Arabic that have 300 million speakers but very little data to learn from. There is not enough data on the internet that was translated. So it's called low resource training. You take one high resource language that has a lot of data, and you take another one that doesn't have enough data. And the second thing, you can sometimes, in many cases, apply direct learning with what's called zero shot, meaning there is no data. For example, you train a model English to Chinese and English to Japanese, and you have data for both of those pairs, but you have zero data between Japanese to Chinese, and neural networks learn and can create a model, direct model, like human brain. If you know 3 languages, you can translate across them. So I think there is a lot of new technologies, at least in some domains, that can make up for less data.
So that brings up an interesting question around the learnings that an AI engine can have when it's applied to a certain domain. And so how do one go about protecting the wisdom of that engine, right? What you learn from applying certain data set, can that wisdom be patented? And how do you protect the IP that's generated by applying in certain domain, or can that be easily copied?
Interesting question. Again, in our domain, in languages domain, I still believe, and again, that's because of the huge scale, that the main differentiation is actually computing power and not the models, and maybe it's specific to specific domains. I would imagine that things like training on proprietary network data might be some IP components. We generally don't believe that there is a big IP component on models or even on data, specifically for languages, but it's probably different by domains.
Yeah, I would say the same, right? I mean, the whole value of the evolution of a system relies on the data itself and domain expertise, right? And domain expertise, anybody in theory could create a model that simulates an LTE call, right, or a VoLTE call, right? I think the whole magic lies into comparing when you have no data, or you have transfer data, or you have transfer models. I think, and I don't know if you can IP this, right? But we're also learning through this process what we should. I mean, Google taught us one good thing, right? If it is innovative enough and thoughtful enough, right? With the scale they have, it will just improve, right? I don't know if you guys do IP in this space, but it just progress, right? And I think it's the same for us. If we are the best guys that we can do LT and modeling and all this kind of stuff, we should produce models that they're really far advanced that people cannot easily copy. But it's a good question on IP. I mean, we're also working on that.
And the other question that comes up almost regularly is talent, shortage of talent of AI engineers and people who are masters of this domain. And that problem, at least in the short term, is not going to go away because there's just not enough pipeline. And so as this fight of talent is going to intensify, what are some ways people should think about addressing that issue, especially in the startup world where people have to hire the engineers, which Google is after, which Microsoft is after, Amazon is after, with top dollars. Even the professors are not immune to this. They constantly get barraged by companies to go work for them. So even in the academia world, doing fundamental research around this can become a problem. So any thoughts on the talent shortage? Obviously, besides putting through more programs to train more people, how do we solve the problem short term, next 3 to 5 years?
Well, I think the whole point of BigML was actually to try and address this problem. And so, if you were a big Silicon Valley company, you can go hire a team of PhDs to analyze your data for you. But what about the rest of the world? And so I certainly see better tools and better designed tools as being part of the solution. No one is going to put all these PhDs out of a job, right? But they don't really need to be working on analyses using existing algorithms, right? They're the ones that are supposed to be out creating new algorithms, out on that cutting edge.
Sure.
The trick is to figure out how to take existing algorithms and actually solve the design challenge of making them accessible to everyone else. And it may be someone who has a PhD just not in machine learning, right? They may have a PhD in biology, and think how liberating it is for them to be able to do their own analysis with better tools. Yeah.
The other issue that comes up regularly is around automation, and there's a lot of debate around the impact on society, impact on corporations, impact on nations' competitiveness. So just want to delve a little bit into it in the sense that, where do you stand? Hinton, considered the godfather of the industry, famously said to a hospital that stop training radiologists or stop hiring radiologists. Obviously, he's toned down a bit on his views on that. But there's this notion of that, a lot of tasks that are repetitive will definitely be automated, and as such, that segment of tasks, and if the task makes up 90% of the job, that job is likely to get eliminated. And we've seen evidence of that in different industries, whether people like to acknowledge that or not. What's your sense of automation and the impact on society? Does this free us up to do more creative things? Or short term we are in this dark period where it will lead to chaos, especially in the Western countries?
So, yeah, I think the challenge we are asked today, especially when you're dealing with, cutting edge technologies, always how the human needs to evolve, right? To be intelligent enough to interact with intelligent machine, right? And if you really think about it, 100 years back or 50 years back, in the lifespan of a person was doing one job, right? So he was starting as a farmer, he was a farmer for his life, he was there as a banker. Now we see this huge transformation within a period in our lifespan. We might need to do 3-4 different tasks. And I started as a computer science engineer, but now you need to start as a unsupervised data expert, right? Or I think the granularity of precision that is happening is impacting everything that we do as individuals. So I think the main challenge is to understand, as you said, evolve and understand how we can interact with the intelligent machine, and also how we can create more advanced things. Like you said, right? I mean, maybe before it was about making a model, machine learning model. Now is how to democratize it, right? It's changing as a function.
Anybody wants to add?
I would also add, and again, maybe it's a view specific to the languages domain, is that in many cases it's unlock opportunities, especially in the emerging markets, actually. That 95% of our usage coming from outside of the US, most of the time in countries that people cannot afford anything up. They just can afford the phone for the first time. They definitely cannot afford the translator. And it unlocks huge opportunities for them to, they will never be able to learn English and master English. And English is de facto the language of the internet. That the first time allows them to effectively use the internet to unlock a lot of social and economic opportunities. So I think there is a ton of things to gain from this technology.
So I have reams of questions that I can go on for the rest of the night and evening, but I want to give this opportunity the audience to ask questions as well, because we have a great mindset here. Just go there. If you could stand up, say your name, and then ask the question.
My name is Alex. I'm one of the leading blockchain integration company. And you've mentioned blockchain in the beginning, and Barak addressed lack of computational power. So how do you see convergence of blockchain and AI, and how do you see AI playing a role in decentralized applications?
And it's a great question around applying AI to adjacent or maybe even new domains, so blockchain and AI, or cybersecurity and AI, and a bunch of other domains. How should we think about it?
Yeah, so I have my previous background is in payments, so blockchain started in payment, but I don't think it's the most successful application of blockchain, and it could go to other areas, but mostly large-scale trading applications, etc. And in my opinion, I might be wrong, most of the time the companies that will be interested and will be doing those large-scale things related to blockchain probably will not have a huge problem with computing power. That's my hope.
I would say, also in Ericsson, we're working a lot with AI and security, right? So how can we, from the trends we see on the network and the patterns we see on the network, we can visualize a security, upcoming attack or something, and also how we can create the areas of concerns that we see under this pyramid of, a lot of issues, a lot of patterns, and then how we all stimulates to few areas of concern that they are really important for an enterprise or a telco or whatever. So I think AI will play a significant role in other distributed functions, right? Security could be one, computer vision could be another one, and definitely the computation can be also intense in those areas.
Yeah.
My name is Jeff Perrone, and I do voice user interfaces, co-founder of a small company. Barak, you mentioned before that a lot of AI is being used to process unstructured data at the beginning. And I was thinking about the recent announcements about using moving images as a way to actually add structure to data to identify objects with much greater efficacy. And I'm wondering, throw it open to any of you, what other kinds of possible ways of structuring data that we haven't been thinking about before might open up new areas to exploration?
I would say that if there is a way to structure the data better, it's great, because not everything needs to be done through AI. There is other effective ways to do it. In my opinion, in many cases, when the data is unstructured, even structuring it requires AI. So to some extent, AI will help to structure the data better, which is a big breakthrough in many areas.
I would say also the definition of unstructured data, it's a little bit ambiguous, right? Because, for instance, look at in our area, in like telcos, right? We have a lot of logs from very different operating systems, network operators, vendors, like other vendors like us. If we don't necessarily have the dictionary of that structured data, it's unstructured to us, right? So that also, as you say, requires a lot of processing. Maybe not always AI, right? But it requires a lot of efforts, and we do a lot of techniques there, even for structured data that they look unstructured, how to make them in a structured way, right? So, I don't.
Yeah.
So Sam Harris and Nick Bostrom have given some really interesting talks on sort of where AI is headed. And before we sort of get down that path, I was actually just wondering if you could all talk about sort of the protection mechanisms you're thinking about putting in place around AI. So one example is you said you have very smart networks, but I believe probably most people here are talking about the flash crash that was caused by almost AI type of trading. So I'm kind of curious for the network that you're building and the projects that you're all working on, what type of protections are you putting in place? Because what's stopping the AI from seeing something that it's never seen before and essentially taking your entire network down?
Yeah. Okay. So I think there is a level of maturity, right, in the authority, in the autonomy you give to an AI model to decide about things, right? And there is a certain confidence level under which we see what are the repercussions, right, to that. So, for example, if you come back, with recommendation for an SLA or something, or a change in the antenna, right, with the 87% confidence level, right? And the rest third thing is that, the whole thing will collapse if you change that parameter, right? I think this is where domain expertise and human intervention is still required in order for a decision as such to take place. So it was mentioned a little bit before, the more you enter, areas where, it becomes critical, the decision point, right? We still utilize humans to understand whether that is a good suggestion or not. So in the beginning of time, we use AI as a prescriptive method, right? And slowly we're moving to just do it operation. So we don't necessarily take critical decisions right now only with AI decisions.
In the context of data analysis, which is what BigML is more focused on, I think giving analysts or data scientists the right tools to evaluate their models is really important, so they don't end up reaching the wrong conclusions. And you see even expert practitioners publishing papers with just overfitted models. You have people who are using supervised learning without an extra holdout set, and then they've overfit their whole model and they publish this paper, and it's a medical paper, and it's like, finding patterns in Alzheimer's that aren't really there, and it's really bad. And so I think that just making it hard for people to make those kind of mistakes is pretty important. At BigML, we've certainly had an emphasis on warning you. We try to make evaluation really easy, number one, and number two, we throw up a big red flag if your model evaluates poorly. And I also think it's just one of these things that, as this whole concept of data science continues to enter the mainstream, it's just one of these sort of basic literacy things, right? Just understanding that it's really easy to overfit your model if you don't follow some basic precautions and procedures.
So one of the things that might help this problem is better explainability of the networks. And what we focus on in Optimizing Mind, we take the networks that have been trained, we're able to convert them to our form, which is not in the feed-forward form, which you can look and see at the inside. And we can tell you exactly what each node is looking for, what is the ideal pattern of each node. With that, you can get a better idea of what your network is doing, what your network is capable of doing, what it's looking for, and so on. Moreover, you can take an input, run it through the network, and see what parts of the input were used to make these decisions. So with better tools of explainability, where you start with the network itself, and then you look and see what the network is looking for, that can help assure what the network is doing and whether it's going to make safe decisions and so on.
I mean, it's an acute problem in medicine or autonomous vehicles and things that directly impact or security or cybersecurity. And so, how does Google think about it?
Yeah, I would say, just to reiterate previous speakers, there is, I think, two aspects to it. The first aspect is that, in my opinion, in areas where the stakes are high, even though AI will be disruptive technology, the productization will be evolutionary, meaning it will start with assistive stuff. AI will just assist people to make better decisions. Even in autonomous vehicles, in my opinion, it will start with drivers will be mostly there, ready to take action. That's how Google doing it today. But a lot of the decisions, a lot of suggestions for decisions will be provided by AI. That's the first thing. And the second thing, I definitely agree on explainability, meaning that Google will build a lot of tools to better understand the system and either correct it or prevent it from mistakes from happening. I would say those are two things that will help driving AI, better understanding of AI, and at some point getting to be more and more comfortable with some autonomous decisions based on the sliding scale where the stakes are.
I mean, it's the whole debate around AI versus IA, intelligence augmentation or artificial intelligence. A lot of people think it's more about augmenting human intelligence versus the other way around. Other questions? There in the back.
Are we still really talking about big data? I mean, back to your point, IA versus AI. AI, in this pure form, is really about self-awareness, right? So have you seen anything in this sort of self-aware area that's starting to really start to point towards true AI versus just big data?
I mean, the whole notion of deep learning and a lot of not just AI but autonomous thinking goes to the notion of how you use the big data to apply to these domains. In my opinion, but see that.
I think some of the applications, like for example the transfer learning and so on, point to some sort of knowledge accumulation that can then be bounced off, and that's a little bit more of the I part, if you will. That once you can piggyback and you can understand what's been previously learned and build on top of it, whether it's explained or not, that's part of the intelligence. Then you're moving a little bit more from the big data, just something statistically crunching, to something that's doing more intelligent things.
Yeah, I go back to what Barak was describing with zero-shot translation, right? There is an intermediate representation of the concepts that allows you to, learn everything to English. Learn Japanese to English and Chinese to English, and then you can just go straight from Japanese to Chinese without having to translate it into an intermediate language. And when you see that happening, it's pretty clear that the machine has actually learned something real. It's not just this mechanical exercise. Is that close?
Yeah, I would just add that in my opinion those two are interrelated in terms of our needs, meaning I think explosion in big data actually drives a lot of needs for AI, because as I said, one of the biggest classical examples is that it was working before in some way, but with explosion of data and with other factors that you cannot just get better results, to some extent AI is the next logical step to get next disruptive improvement in quality. And again, classical example is translations, that we could do it with a lot of data before on statistical manner, but it plateaued, especially on what we call fluency, meaning you could translate it accurately, but because we were breaking each translated sentence into chunks, the translations were a bit quote-unquote broken or not grammatically correct, especially if you translate between two languages that are very linguistically different, let's say Japanese to English, you would get effectively Japanese syntax and grammar translated word by word or chunk by chunk to English. And then the next step, when you have big data, is basically take each sentence as a whole and reorder it and provide much better accuracy, but also better fluency, meaning it sounds much more human, less like a machine. So that's, to me, it's very interrelated, because a lot of use cases are driven by explosion of data and understanding that older technologies just break out and cannot work effectively.
And also, I would just add also on the computer networks domain, right? Having inferred relationships which are not necessarily being seen before, it's also very, very important to us, because if you have A equals B and C equals A, you can make a relation without necessarily this haven't happened in the network before. So you go B equals C, and then you can predict and remedy an issue that it hasn't happened before, which really moves with the explosion, as Barak said, of big data, really helpful to us to create automated learning, self-learning rules.
So, when do you see the limit of AI? And just an example, I love Google Translate, but it does very well, except that it's all about the last word. So there is a meaning in the word, so translating from English to French. There's few words that did not come through, and so then you have to have a person to intervene to support the AI. And it seems to me, hearing, or even like when you do a customer support, okay, can AI really answer all the questions, or I guess where is the limit of AI? United would be an interesting example to discuss.
Yeah, go ahead.
So I see two limits of AI that the brain has, that the AI doesn't. One is the explainability, but the second one is updatability. So the brain has the ability to see something once. If you see something once and you're inclined, it's interesting for you, you're able to learn it immediately right there and then, You don't have to go back and update your networks and rehearse it with all the old and the new, and you immediately have it again for use for the second time. That's something that AI doesn't have. People work on what they call one-shot learning, but still it requires several times of rehearsal and so on. And you can see that with Siri, for example. If Siri makes a mistake, you can't say, okay, Siri, what do you expect for this word? Give me the sounds. I'll type in the word. Give me the sounds. What do you expect? I'll say it. That's one thing you can't do. And then the other thing you can't do is like, okay, Siri, I'm going to say this word. Just use this word. When I say this word, just write that as that word. You can't do that updatability in one shot. And those are the limits that are still significant in the AI today compared to what the brain can do.
So how far are we from actually doing that?
I think as long as we are still in the structure of feed-forward networks, that's part of where that difficulty is. You're getting to the limit of that type of structure where you have to rehearse and adjust all the weights. The brain doesn't work like a feed-forward mechanism. There's much more feedback connections, and there's strong evidence that all of those feedback connections are being used during recognition, right? It's not we, optimize and then we learn the weights and then we just, do the weights like that. So I think until we look at the feed-forward feedback algorithms, we're going to be stuck with those limitations. And just might as well, since we're here as a plug, that's the key that allows us to be able to take an arbitrary network and to tell you and explain what are the patterns within it. What we basically do is we take the feed-forward network, find an mathematically equivalent feed-forward feedback network, which we can then explain. And without that, it's very hard to do these explanations.
Yeah, I agree. As I said, I think human brain is great in big pictures, facts and details, and that's one of the challenges of at least current generation of neural networks. Even if it's possible to get to that level, the amount of computing power, not to beat on the dead horse, but the amount of computing power to take all the context into account is enormous. And to make all the decisions all the time, it's a ton of computing power that is very hard to do. I would also say that's why I believe that the natural evolution initially would be assistive. In classical example of radiologist, a radiologist might get, big picture right 90% of the time, maybe 95% if they're lucky. But in those 10%, if assistive AI will say, hey, your big picture is right, but you haven't looked at those 2-3 variations, those 2-3 exceptions, maybe you should take a closer look. That's to me a huge value in this particular domain. So as I said, I'm pretty optimistic despite the limitations. There is a lot of value to be gained.
We're kind of running out of time. So I wanted to ask the last question around, if we get rid of all the problems around privacy and regulations and just wear your engineering hat, what excites you the most? What kind of problems you think are on the horizon that we'll be able to cut through in the next, 5-10 years? And we can start with UTM.
For us, our biggest bet is 5G, low latency, high bandwidth networks, right? To make them more predictable, more open, and more adaptable, right? Is definitely something we look for, right? And we can use AI and other techniques to make it more open and much more predictable, as I said, as a network. But this horizon of enabling connectivity to predictivity is something that we at Ericsson feel very passionate about.
Ericsson has the whole theme of network society. So how does that 5G capability help other industries as well as society at large?
Yeah, so the whole point about 5G is aggregating the different mediums of connectivity, right? Creating one ubiquitous platform for people to innovate. And that includes, traditional industries that haven't been on IP domain, industrial IoT and all those kind of things. narrowband technologies that would be utilized for leaders and sensors and all this kind of stuff. Even cars, with machine to infrastructure, car to infrastructure, vehicle to infrastructure. So all this area of unleashing internet for everybody else, like connectivity for everybody else, is very exciting for us. As the first wave we had on 4G was all about humans. Right now we're moving into the things, and that is very, very exciting.
Sweet. I'm a little bit unique. I do have the engineering background, but I don't really think like an engineer.
I think like a neuroscientist.
Yeah, so my interest is understanding the brain and using AI to understand the brain. What's in the AI that's not in the brain, and how can you make the AI more brain-like, and to see, for me, the biggest interest is changing the structure and then seeing some of the phenomena that you would see in the brain, like bursting, that there's these other phenomena, difficulty with similarity, and so on, where things that are similar take longer to recognize, and things that are asimilar, you don't see these phenomena in your feed-forward AI.
So do you think we'll be able to explain the brains of head of states?
Let's not get ahead of ourselves.
Well, follow the money, I guess.
Okay.
So, from the perspective of data analysis and using machine learning for data analysis, I'm pretty excited about what goes by the name meta learning. And for those of you who've actually done predictive modeling, supervised learning, unsupervised learning, you're probably familiar with this. Let's say you want to train a classifier and you want to pick an algorithm. Do you really have some strong hypothesis about why you're going to pick an SVM versus a random forest versus a neural net? And the answer, 99.9% of the time, is no, you do not, right? And so there's all this kind of random experimentation that goes on in terms of selecting the algorithm, and in terms of just creating the whole pipeline upstream of your algorithm. Maybe you're doing some feature selection or whatever, obviously tuning the hyperparameters. All that stuff just gets automated, right? That is clearly where things are headed. At the lowest level, you have the hyperparameters. Above that, you have algorithm selection, which, again, I would argue is highly automatable because you don't have, most of the time, any good reason for picking one algorithm versus the other. And then I think it goes beyond that to actually automating entire pipelines. And so that's what I'm excited about, is this futuristic tool where you put together your training set, you give it to the algorithm, you tell it kind of broadly what you want it to do, it kind of handles the rest, and maybe it asks you a clarifying question once in a while, right? And all of this sort of brute force thrashing around that you have to do right now, that just goes away.
Yeah. Last word.
I'm personally very excited about the concept of transfer learning, and especially zero-shot learning. Ability to take two models, one with a lot of data and the other with little data, and create one model that will benefit both. And especially taking models with data and building models where you don't have any training data is just mind-blowing. And I hope, and if it's true, and I hope it is, that it can be applicable for many areas beyond languages, the classical English to Chinese, English to Japanese, and then you basically do zero-shot to Japanese to Chinese. If it's applicable to other areas, this will be like a really revolutionary move, because it will allow us to scale AI to many, many areas.
Well, thank you very much. I think it has been, as you can see, we can go on for a couple of hours. Before we head out, I just have a couple of books to give out. And so for the first question, I wanted to ask you, what was the year when we surpassed 5 billion unique users, mobile users, connected users on the planet? What year did we pass 5 billion mark of unique users?
Data or 2014?
Connections. Cellular connections.
2014?
No.
2012.
No.
2016?
No.
2015.
It's actually a trick question. It hasn't happened yet, but it's going to happen soon. Okay, what year is going to pass?
2020.
2017. Well, our panelists get the prize. The second question is, which month did the Dartmouth workshop start? In which year?
1957?
Close.
56.
Month.
56.
Month. Yeah, June 56. There you go.
Thank you.
Well, thanks to Mario and MobileMonday and Google Launch, and thanks to all the panelists for a fascinating discussion, and thanks to all of you for showing up.